For centuries, physics was guided by a quiet confidence. The universe appeared orderly, consistent, and ultimately explainable. Every new discovery seemed to reinforce the idea that reality could be reduced to laws, equations, and predictable outcomes. The deeper physics went, the more control it seemed to gain. Knowledge felt cumulative, understanding felt inevitable. That confidence did not disappear overnight, it eroded slowly. The first cracks appear when time stopped behaving like a universal backdrop. Relativity revealed that time bends, stretches, and slows down. Events that seemed simultaneous were no longer absolute. The universe was not unfolding on a single clock, reality depended on perspective. What felt fundamental turned out to be conditional. Then matter itself began to resist explanation. At microscopic scales, particles refused to act like objects. They had no definite position until measured. They followed no clear path. Cause and effect blurred into probability. Physics was forced to abandon the idea that reality exists fully formed, waiting to be observed. This was not a failure of instruments, it was a failure of expectation. We expected the universe to behave intuitively. We expected smaller scales to reveal smaller versions of the familiar world. Instead, physics encountered something radically different. A domain where certainty dissolved and description became statistical. Where reality could only be spoken about in terms of likelihood. Quantum mechanics did not introduce mystery for the sake of mystery. It introduced honesty. It described reality as it behaves, not as we wish it behaved. The equations worked perfectly, but the meaning behind them became difficult to express. Physics could predict outcomes with precision, but could no longer explain what was happening in familiar terms. This created an uncomfortable situation. Physics was succeeding without understanding. The calculations were accurate, the interpretations were not. At this point, many people assume physics becomes speculative or philosophical. In reality, the opposite happens. Physics becomes more disciplined. It stops pretending to know what it cannot justify. It accepts limits without surrendering rigor. It continues forward, not by claiming truth, but by refining approximation. This is where the idea of failure must be reconsidered. Physics did not fail because it encountered limits, it succeeded because it revealed them. Limits are not obstacles to knowledge, they are part of what knowledge is. Every theory works within a domain. Classical mechanics works at human scale, relativity works at cosmic scale. Quantum mechanics works at microscopic scale. Problems arise when we demand a single framework to explain everything. Reality does not organize itself around human desire for unity. The deepest conflict in modern physics, the inability to reconcile gravity with quantum mechanics, is not just a technical problem. It is a sign that reality may not be compressible into one coherent picture. The universe functions seamlessly, but our descriptions fracture. This fracture tells us something important. It suggests that explanation is not the same as existence. Reality does not depend on being fully described. It does not pause where equations stop, it continues regardless of our confusion. This insight extends beyond physics. Human identity operates under the same illusion of completeness. We expect the self to be consistent, stable, and fully knowable. Yet when examined closely, identity behaves like a quantum system. It changes with context, it stabilizes through repetition. It dissolves under scrutiny. Thoughts arise without warning. Emotions appear without cause we can fully trace. Even the sense of I fluctuates depending on memory, attention, and situation. Stability is not fundamental, it is emergent. Physics reveals its pattern outwardly. Experience reveals it inwardly. In both cases, what seems solid is the result of averaging, not essence. Reality appears stable because instability cancels itself out at scale. This realization does not undermine meaning, it repositions it. Meaning is no longer something abstracted from final answers. It is something found in attention, in careful observation, in the willingness to stay present where certainty ends. Physics teaches us how to ask questions without demanding closure. It trains the mind to operate without guarantees. It shows that understanding can deepen even when explanation stops expanding. This channel exists in that spirit, not to simplify reality, not to replace uncertainty with belief, not to promise clarity where none exists, but to explore the boundary where physics stops offering comfort and starts offering honesty. Reality does not need to be fully understood to be real. The universe does not need to be explainable to function. Experience does not need to be resolved to be lived. When we release the demand for final answers, something else becomes visible. A quieter form of understanding, one that does not depend on concepts, but on presence. Physics does not bring us closer to certainty, it brings us closer to reality. And reality, as it turns out, is not obligated to fit inside our expectations, still within.